This is the Bellman Ford algorithm. It's about single source, shortest path, okay? And it deals with dynamic programming where things change as you go along. And it also accepts negative edges. So the way we do it, we're going to take the current value plus the distance, the edge length. If that's less than whatever is the destination, then we can add that. So let's look at this. These are the total number of edges. I have A to B, I'm going to include that. A to C, that's A to D. B to E, that's the only one, B to E. C to E, so C to E, C to B, D to F, D to F, D to C, E to G, and F to G. So since there are 1, 2, 3, 4, 5, 6, 7 edges, nodes, or vertices, we're going to go through this 6 times. Now this is how it works. So we're trying to compute, shortest distance, single source. Now I'm going to set the original to 0. Everything else is infinity. That's infinity. This is infinity. This is infinity. This here is the distance, meaning that from A to any of those, the distance is infinity. So watch this. So let's do this now. This is where the Bellman Ford comes into. Now this is 0 plus 6. See? 0 plus 6. If it's less than this, well, definitely it is. So 6 is less than infinity, so I'm going to put 6 here. Alright, that's this one. Now, how about A to C? A to C. 0 plus 5 is 5. It's less than infinity, so I'm going to change this to 5. A to D. 0 plus 5. It's also less than infinity. I'm going to change this one to 5. Now, how about B to E? Well, B is 6 plus negative 1, so it's 5, which is less than infinity. How about C to E? C to E. I get 5 plus 1, 6. Well, leave it as it is because 5 is less than 6. 5 plus 1 is 6. How about C to B? Well, 5 plus negative 2, which is going to be 3, which is less than 6. So I put that to 3. 5, that's a 3. Okay. Now how about D to F? D to F. 5 minus 1. 5 plus negative 1. So that's a 4, which is less than infinity. How about D to C? Well, D to C, you get 5 plus negative 2, which is 3, and that's better than 5. Okay, how about E to G? E to G. 5 plus 3, that's 8, which is better than infinity. Okay, F to G. 4 plus 3, which is 7, that's better than, okay. So this is my first pass. So I've done this once. I gotta do it 5 more times. Hopefully, I'll have changes. Now, let's go it the second time. Okay. A to B, 0 plus 6, so no change. A to C, 0 plus 5, that's no changes, it's 3. A to D, 0 plus 5, that's a 5, so it stays. Now, so I got these 3. How about B to E? 3 plus negative 1, that's a 2, so it's better than 5. Okay, how about C to E? C to E. 3 plus 1, 4, well 2 is better, leave it. C to B. 3 plus negative 2, so that's a 1, that is better than 3. Okay, how about D to F? Well, I got D to F. I have 5 plus negative 1, that's a 4. That doesn't change. How about D to C? D to C, 5, negative 2, that doesn't change. E to G, 2 plus 3, 5. 2 plus E to G. 2 plus 3 is 5, that's better than 7. How about F to G? 4 plus 3 is 7, so that doesn't change. This is my second pass. Okay, I'm going to go through it third time, because remember we got 6 times. A to B. So 0 plus 6, that doesn't change. A to C, 0 plus 5, that's a 3, doesn't change. A to D, 0 plus 5, that's a 5. B to E, so B, which is 1 minus 1 or plus negative 1, that's a 0, so that's better than 2. Okay, how about C to E? 3 plus 1, that's a 4, 0 is better. How about C to B? C to B, 3, negative 2, so that's a 1, that stays. D to F, D, 5, negative 1, 4, that stays the same. D to C, 5 plus negative 2, that's 3, doesn't change. E to G, 0 plus 3, 0 plus 3 is 3, so it's better than 5, okay? How about F to G? Well, F to G, I got 4 plus 3, 7, that doesn't change. So this is my third pass. Number 4, fourth time. Okay, so A to B, 0 plus 6, doesn't change. A to C, 0 plus 5, doesn't change. A to D, 0 plus 5, because that's a 5, doesn't change. B to E, 1, negative 1, 0, doesn't change. C to B, 3, negative 2, that's a 1, doesn't change. Okay, D to F, D to F, 5, so that's a 4, doesn't change. D to C, 5, negative 3, that's it, doesn't change. Okay, how about E to G? E to G, 0 plus 3, that's a 3, it doesn't change. F to G, 4 plus 3, 7, it doesn't change. So, during the fourth pass, there were no changes made, so there is actually no need to continue. So all I have to do is now write my values. If you look at this, A is 0, B is actually, what is B? That's a 1. C, what is the value in C? That's a 3. D, what's a D? 5. D is 5. What D? So then I have F. What's at F? F is 4. And then G is, what's at G? What's the value at G? That's a 3. That's it. So this is what we mean by dynamic programming, and this is my table that I saved. So this algorithm is known as the Bellman Ford. The important thing about this algorithm, it accepts negative edges and it single stores shortest path, and that's it.